In this presentation, we'll go over the second set of practice truth tree problems. As we did in the previous lecture and the practice problems, I'm just going to keep on using the same procedure over and over and over and over again. So things are going to sound very similar as they did to the previous lecture, which is part of the point of logic, is the fact that we're just following these rules and using the rules to reach some end and then evaluate the logical sequence that we are given. So as we did before, we want to look at what our premises are. Here's our premises. Here is our conclusion. So we're going to start by listing our premises on the left-hand side of our line. Again, I'm using the color green for true, red for false. So we want to put our true premises or premises on the left-hand side because we're treating them as true, and we're treating our conclusion as false and looking to derive a contradiction. There we go. So as I did before, I'm just going to start with the first premise, which when we look at it, we want to determine what the main operator is so we know which rule we can use on it. Here we've got parentheses closing this off together as one. Here's the other side, so we know that our arrow is what's the main connective. So what's the arrow rule if it's true? Well, true means it's either the left side or the antecedent, as we call it in logic, is false, or the conclusion is true. So either the left side is false or the right side is true. Since it's an or statement for the evaluation, we branch out. Now we can't do anything with the P, but we could still do something more with this R or not T. So I'm going to break it up. The main operator here is the wedge. So what's the rules for a true wedge? Well, either the left side is true or the right side is true. So again, it's an or statement, so we're gonna go ahead and branch off. We'll put R here, not T here. Clean this up a little bit. There we go. So we just took our evaluation rules for our wedge being true, and it's one or the other. So we branched like that. Then we just got to flip this T over. So for any tilde, just remember that when we have a tilde, we just flip it over the line and get rid of the tilde. So we've broken everything down to the simplest parts, P, R, and T. So that one is done. We can check it off. There's nothing more to do. Let's look at this second premise. So second premise, again, we have a arrow as the main connective. And what makes an arrow true is if the left side is false or the right side is true. So left side false, not T, and the right side is true, P. And remember that whatever happens above, we have to filter down here into the other branches below. So we're just going to repeat the same thing that we just wrote there, not T, not T, P, P. We got to flip this T across. So flip this T across. That. That. Now, as I said before, you can evaluate these trees whenever you want to. We still have our conclusion to do. we've done that one. And remember, we have to do it everywhere on the tree. So that's why you see the same thing in 3 different spots. So that these 3 things are just all the same thing done over. So, as I was saying, we could go ahead and evaluate things and close some branches off if we want, because we got a P here and a P here that cancel each other out. One's on the right, one's on the left. We also have a T here and a T here. And that's it for right now, it looks like. So we could close off those 2 branches, but I'm not going to, just so we can follow through. Now the amount of room that I need to do this though is going to make it a little bit more difficult. So what I'm going to do is I'm going to erase this. Get over here. So let's see. I had just going to redo this side real quick. Sorry about this. I should have made myself a little bit more room when I was doing it. So remember when we were doing this, we were bringing the P down to here and had to do not T, T, P. So that should get us back to where we were. I just need a little bit more room because we still need to do our conclusion here. And what makes a biconditional false? Well, is where they don't match. So gotta break these up. We need to make it so we have one side that is a P that is true and an R that is false, and one side where a P is false and an R is true. And we got to repeat that on all the lines below, or I guess all the branches. So as you can see, this gets a little bit wide at times, which is why it's sometimes nice to close off branches when you can. So we just got to repeat the same thing on all these different branches. One where there's a P here, an R here, P here, R here, P here, P here, R here, P here. Get a little bit more than that. P here, R here, P here, here, and then an R here, P here, here, here. You can see how these things can get pretty tedious because as they get wider, they just get more involved. Alright, so again, we just had to do the same thing. How many times is that? 1, 2, 3, 4, 5, 6 times. And so all those are just this getting broken down at those points in the truth tree. So now we got to evaluate. We've broken everything down. We're done to here. So what we're doing when we're trying to figure out if there is, or whether or not this is a valid or invalid sequence, we just are looking for things that appear both on the right side and the left side up the tree. So here I got a P on the left side, a T on the left side, P on the right side. So right there, there's a contradiction. I got a red T, or I got a red P and a blue P, or green P, sorry. So that closes that one off. I have on the next branch, I have left R, right P, left T, Doesn't look like I have anything that closes off. Now let's go back through just to make sure. Got a green R, red P, green T, red P. Nothing closes off. So that one is open. Let's look at the next one. We have got 2 green P's. Well, got a red P up here, so that closes that one off. Same thing here. I've got a red P and a green P, so that closes that one off. Looking at the next one, I have a red R, a green P, green T, green R. Oops, that was supposed to be yellow. Yellow, yellow. Close that one off. Let's see, next one. Red P, green R, green T. Nothing. Nothing closes it off, so we leave it open. Double check. Green R, red P, green T. The green R. Yep. Let's look at the next one. We got red R, green P, green R. So we got those two that match. So that one's closed. Let's see. Got a green R, red P, green P. Right there, so that one closes. Got a red R, green P, green T, red T. Right there. And we're going to be able to use that same one right here. Let's see, next one. We've got a red R, green P, green T, or red T. Looks like that one's open. And then we've got a red and a green P, so that one closes. So again, what makes it close off is if there's the same letter on both sides of the tree somewhere in the same lineage. So, since we do have at least one, we've got 3 different open branches, we know that this is going to be invalid. And if it's invalid, we have to write a counterexample. So we find the different letters that we've got. We've got P, R, and T. P, R, and T. And we could choose any one of these. It doesn't matter which one we choose to list our truth values. I'll just pick this one. But the nice thing about logic is when we know something's invalid, we just need one instance in which it's invalid. That's all you need to be able to cite. So here we've got a green R, so that means it's true. We've got a red P, that means it's false. We've got a green T, that means it's true. We could just as easily use this one or this one, and they would have had slightly different values, but it's fine. Doesn't matter. One counterexample will do, as long as you know that it's invalid. So that's the first one. Let's move to the second one. So, same process as before. Let's look. Here's our premises. And here is our margin. So let's just write those down in our truth tree. So we start with the premises on the left. Stay consistent with the colors. P or S and T. T arrow L. And then our conclusion on the right, meaning that it's false. So let's start with the first premise. We gotta look at what the main operator is. So we have this tilde with this p, we have these parentheses offsetting that, so our main operator is the wedge. So that tells us that we need to use the wedge rule. I'm going to branch this one out a little bit further. Shouldn't need as much room on this one, but just in case. So our wedge rule is that one of them has to be true. So we'll write the left one here as true, and we'll write the left or the right one here as true. Remember, left side's true, right side's false. We need to flip over this tilde p to get rid of it. So we're taking this and we're flipping it over. And then we got to break down our S and T here that's on the right side. And what makes a conjunction true is if they're both true, so they stack. So now we've taken care of this one. Let's look at the second premise. So our second premise is just an arrow. And what makes an arrow true is if the left side is false. T. If the left side is false, or if the right side is true. That. Taking this one, it's there and there. So that one is done. Now we just have to do the conclusion. Main operator there, it's going to be the arrow. What makes an arrow false, because it's on the right hand side, what makes an arrow false is where the left side is true and the right side is false. Same thing gets put on all these other branches. Further. So wherever the left side, meaning not P, is true, and the right side is false. So right side false, left side true. I know that looks a little confusing with all those lines there, but again, same thing in the same spots, just have to put them on all the branches that you use down below. Now let's go back through and look to see if we have a valid or invalid sequence. So we're looking for things. Oh, actually, I take that back. We still have one more thing to do. I'm going to flip that tilde p over. So we want to take that tilde p, change it into just a regular p. So we just got to get rid of these tildes here by flipping it across the way. So it's always good to just check your work when you go back through these, because one little mistake can throw the whole thing off. So just gotta be careful, gotta go slow. So let's look to see if we have anything that cancels out. Well, I've got a P on the right, I've got a L on the right, I've got a T on the right, I got a P on the right. So nothing is closing out there. I've got a P on the right, an L on the right, and an L on the left, so I do have something that closes out there. Here I've got a P on the right, L on the right, T on the right, T on the left, so that does close off. And then I have a P on the right, L on the right, L on the left. So that one closes off. So I should have circled these two before. So this one closes off. So now, even though there are more closed branches than there are open branches, this is still invalid because there's at least one open branch. And since there's one open branch, we just mark it as invalid. Make a counterexample. list all the different letters that are in this. P, S, T, L, P, S, T, L. Is that right? That's right. S and T, S and T. So we have a P that is on the right, so that makes it false. Don't see an S, but do see a T that is false and an L that is false. So now what's interesting here is that we don't have anything for S in this tree. We have a P, L, T, and no S. So what that actually tells us is that it could be either true or false. It doesn't matter. I could write true or I could write false. But what it's saying is that S has no bearing on whether or not this will work out, because no matter what the combination here of P, T, and L, or with the combination of T, L, and P all being false, it's automatically going to be invalid. So S doesn't really have any bearing, which is fine. So when you don't see it in your tree and you're trying to make an evaluation about whether or not what the truth value is of this counterexample, it doesn't matter which one you list. You could write either or. Because again, we need a definite counterexample with truth values for each letter. But in this instance, because it doesn't show up in the tree, it just means that it doesn't have any sort of bearing on whether or not that it is going to end up being valid. So, same process as before. I'm not going to circle the premises this time just because I always have to erase them. So to try to speed things up a little bit, here, put our premises, S, and just Q by itself, P and S. Now let's just look at this one first. What's the main operator? Main operator is the ampersand, because this goes together and this goes together. So what makes an ampersand true is if they're both true, both sides. So we'll separate them to P or not Q, S, that's S. Then we still need to break down that P or not Q. So what makes a wedge true? Well, what makes a wedge true is if one side is true. So we'll just write the P here, not Q here. We still have to flip that not Q, and now we're done with the first premise. Now let's look at the second premise. Well, the second premise is just Q by itself, so that's of no importance. Get rid of this yellow. Don't have to do anything to that. Then we got P and S, which is false. So what makes P and S false is if one of them is false. So you just put P, S. So again, just the same thing twice because we got to break it down in both trunks, both branches. Now we can go back through and we're just looking for contradictions. We have a not P and a P. So that tells us we have a contradiction there. We got a red P and a green P. Got a red S and a green S. Got a red Q and a green Q, and that's going to filter down into both of these, so they all close off. So this one should have been relatively easy, not too much going on here, so not too spread out or too many branches, but as you can see, we have them all closed off, so that means that this is a valid sequence. And since it's valid, we don't have to provide a counterexample, so there's nothing more to do. let's look at this fourth one. Same thing as before. I'm going to start going a little bit faster. And just cutting out a couple of things that I've been doing, but I'll try to make sure I'm still as thorough. But we just want to list our premises here. Q, and then our conclusion here. Now, let's just start with this premise up here. What's the main operator? Well, the main operator is the arrow. So, what's our arrow rule for something that is true? What's a true conditional? Well, conditional is true when it's either its antecedent is false or its consequent is true. And we just need to throw that Q across the line to get rid of the tilde. So that's all we need to do for this one. Now let's look at this next one here. So what's our main operator? Our main operator is the arrow once again. So what makes an arrow true is if the left side is true, or sorry, if the left side is false or the right side is true. So we're going to do the same thing to both of these branches, because we have to do the same thing on both sides. Q here, put a Q here. Again, you might already see, well, I've got a Q here and a Q here, so I know everything's going to close off that comes from this branch, but I'll just keep going either way. If you want to close that one off when you're doing it for the exam, you're more than welcome to. It cleans up the tree, makes it a little bit easier, but you don't have to. I'm not going to put you to it. As long as you get the right answer, that's all that matters. So, now we got to break up this T double arrow R. So what makes a biconditional false is where either the left side is true, or sorry, wherever they don't match. I'm just going to put it that way. And I'm just going to put in here at the same time. T, T. So that finishes that one. Now we just need to do our conclusion. Our conclusion, the main operator is a tilde. Drop these down. That. So we're taking this now. I just want to flip it across, so I'm going to put a E and R, E, R, P, and R, P, and R, P, and R, and then we just need to break those down. What makes a conjunction true is if they're both true. Like this. And that is it. Finish that. Now we just need to go back through, check to see if it's valid or invalid, looking for letters that appear on both sides. I got an R here and an R here. So I know that one closes off. I've got a P here and a P here. So green P, red P. And oops, forgot to get this other line open. Again, this is why make sure you always double check what you got going on, because I forgot to put the conclusion here. Like that. So bad. And because that's where we're gonna get our contradiction from. Got contradiction here. Let's see. ERTQ. Double check, but that doesn't look like there's one there. R P R T Q. Nope. Looks like that one. And let's see. We got our Q and Q here, like I said before. Closes that one. So again, we only have one open branch, but one open branch is enough to make it invalid. So do a counterexample. What are all the letters that we have? We have a P, we have a Q, we have an R, we have a T. And we gotta just look at what they are here in our tray. We've got a true P, we've got a false Q, we've got a true R, we've got a false T. So it's invalid because of those values there. True R, true P, false T, false Q. On to number 5 here. So same process as before. P, Q, and then that. Something tells me this one's going to be quite branchy. So there are a lot of conditionals in here. So P, Q, Q, R, R, P, S, and then S, tilde, tilde, P. So let's just start with the first premise up here. It's a conditional as the main operator. So I'm going to branch this thing out. What makes a conditional true? Well, it's if the left side is false or the right side is true. So put the P arrow. So that's so P arrow Q, Q arrow R. Now we got to break those ones down. I'm just going to do this one first because I know I'm going to need to branch it. So it's another arrow. So we know left side false, right side true. Over here, what makes an arrow false is if the left side is true and the right side is false. Again, this is all in the rules that was set forth in the first lecture on truth trees. So if you're wondering why am I doing what I'm doing for each one of these, well, it's because there's a specific rule to follow for if it's true or if it's false, depending on the main operator. So if you're really lost at this point, make sure you realize that you need to have those rules at hand and make sure you understand them, that there's a left side and a right side to each operator with the exception of the tilde, and that there's different ways in which they will either branch or stack depending on if it's true or false. That's why there's 10 different rules. There's 5 operators, there's true values, and there's false values for them. So just in case. Well, now we're done with the first premise, so let's look at the second premise. our second premise is also a conditional. So we're going to branch it out into if the left side is false, the right side is true. Same thing on these other branches. P S. Then we've got to do something about that P or S. What makes a wedge true is if one of them is true, so we got to branch it out again. Oops. Side. Again, we can get like these things get a little confusing, so make sure you check your work as you're going through. So like that. So now we've got the second premise done. We can see that things are already pretty wide, and we still got to do this last one. Now it is a tilde, or it's the rules for a false conditional. So what makes a conditional false? It's going to be if the left side is true and the right side is false. So I'm trying to elongate these a little bit. So it's wherever the left side, so the S, is true. And the right side is false. P, 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 there's an extra tilde in there. Once again, these things can get a little cumbersome at times. P, 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 not P. Sorry, that's not the best. Self not P. So now we gotta rotate these P's across, so we gotta get rid of one tilde at a time. P, not P. Then we gotta flip them right back over. So you might say, well, how come we just can't get rid of the two tildes at once? Well, again, logic has to be told exactly what its rules are. So you can only do one thing at a time. So, make these things longer. Again, I can understand if like there's so much going on here. That's why it's a little bit easier to do on a piece of paper on a much larger whiteboard. But so let's go ahead and track back through these branches and see if we can find any contradictions. First one, I've got a red P here and a green P here. That's going to close off there. Same thing here. Same thing here. go. Let's look. Oh, forgot to. E, B. Now we need to see PSRQ. Not seeing one there. That one looks open. PSRQ. P, green P, that one cancels. We've got. Doesn't look like it cancels out there. Let's see. PSR. Now we got R and an R. That one will cancel out. We've got P and P. That one will cancel out. PSS and R. Doesn't look like that one cancels out. That one looks open too. PSSR. Yep. So we've got 3 different ones that are open, so that tells us it is invalid. So we've got a counter example. We've got P, Qs, Rs, and S's. So P, Q, R, S. So I usually just do whichever one's the first one from left to right. So we could do this one. So I've got a red P, which is false. Have a green S, which is true. Red R, which is false. And a red Q, which is false. Now, again, if we would have used one of these other ones, say like this one, I've got P, S, and Q, but I don't have R. That's just telling me that R doesn't play a role in determining whether or not this thing is valid or invalid. It's just inherently invalid without the value of R factored in. So, and then I think here we have P, S, and R, but no Q. Same thing applies there. You could put any value of Q if you wanted to do that one. That would also be fine. So on this one, we only have one premise. So this one should be not as bad as some of the previous ones. Should be a little bit shorter. Let's say, don't give myself enough. And gotta put my conclusion right, meaning that it's false. And so let's look at the premise first. The main operator there is a tilde because it's in front of everything else. So we'll flip it across. P, double A, Q, or S. Now what makes a double arrow false is where they don't match. So we'll say this side is where P is true and Q or S is false, and we'll say this side is where P is false and Q, S is true. We still need to break down these wedges. Let's look at this first one. When is a wedge false? Well, it's false when both of them are false. And when is it true is when either one of them is true. Like that. So now we've broken those down as far as they'll go. So that one is done. Now we just need to look at this conclusion. What makes a conditional false is where the left side is true and the right side is false. And then the thing we have left to do is flip this tilde p across line. Now we can evaluate. I saw this one, so got S's on both sides, so that closes off. I've got P's on both sides, so that one closes off. And same thing here, I got a P and a P, so that one closes off. So, since all of them close off, this one has to be valid. No counterexample needed for a valid sequence, just have to close them all off and show your work and say that it's valid. So we got two premises this time. So we got P or not Q and not S, and not P and S. So let's look at the first premise. It is a wedge, so makes a wedge true as if one side is true. P or Q and S. We gotta do something with this Q and S. And it's got a tilde in front of it, so the first thing we gotta do is flip them across. That. Now we gotta say what makes a ampersand false is if one of them is false, so QS. So that breaks down our first premise. Now we just need to break down our second premise. Make these a little bit. So our second premise is a tilde piece, so we just have to flip it across. There. So just so you don't get confused, these P's are coming from here, not from here. So, not there. So that's where they're all coming from. Now, we just want to go back through, see what we've got. If we've got any contradictions, we've got P on the right, P on the left, closes off. We've got a P on the right, Q on the right, S on the right. That one will be open. And we got P on the right, S on the right, S on the right, and don't see a Q there, so it doesn't matter. So, we know that this one's going to be invalid. We need a counterexample. We have three letters. We have E, Q, and S. I'm just going to look at this first one. P, Q, and S, they're all false. So we know that that is one of our counterexamples. We could have done another counterexample over here where P is false, S is false, and then we could have said Q is either false or true. Doesn't matter. I just, again, went with this first one because I usually just read left to right. So that one is invalid. So this one we have two premises. We have tilde S, T, arrow R, and not S and not R. We have not T as our conclusion. Let's do the first premise, which the first premise is a tilde as the main operator, so we're going to flip it over. Like that. Now we still have more to do. We've got a wedge as the main operator. What's a false wedge is that they're both false. And what makes this conditional false is if the left side is true and the right side is false. So all of this is this first premise. Everything stacked up. There was no branching, and that's just following our rules again. So make sure you're familiar with the rules, know how to use them, depending on if it's false or true. And so that's the whole first premise. Let's move on to the second premise. The second premise is going to be not S, not R. We have to flip those across. We got S, R. And that's all that we have to do for that premise. So that's coming from there. Now we just have our conclusion, which is a T. And I should give myself just a little bit. Should be right. So we just gotta do the T, which gets flipped over to here. So just to break it up again so you can see it. This one's this one. This one's this one. This one's. None of them branch out, just following our rules. So now let's look. Do we have any contradictions? Well, I've got an R, an S, an R, another S. They're all on the right side. I've got two T's on the left side. Nothing cancels out, so it is invalid. So our only branch is open. So that gives us a counterexample. And we have S or R, S, and T. And T is true. It's on the left. We got a red R because it's on the right, which makes it false. And we've got an S on the right, which is red, which makes it false. So right there is our counterexample. There's only one counterexample because there's only one branch. So again, this one's different than the ones we've done before because branching never happened, but this is just following the rules for each of the operators. So this one's invalid, and that's our counterexample. Here we've got two premises, so same thing as all the other times. Start with the premises on the left. Q, QT. Put the conclusion on the right. Let's look at this first premise. What is it, or what's its main operator? Its main operator is the double arrow. So we'll branch it out because what makes a double arrow true is if both sides match. So, actually not going to put that parenthesis there. Need it. S arrow, not Q. And then I want to write them as both false. So I still need to break down these conditionals. This one on the left-hand side, since it's true, the left-hand side could be false or the right side could be true. Again, if you're a little lost on why I'm doing these differently for each conditional, remember that the rules are in the first lecture and that we just use the rules that we use. Logically, they make sense. Logically, meaning like when we use them in conversation, they seem to make sense as to what their truth values are based on our comprehension of them. So we use these set rules when we're doing truth trees. So again, if you're a little lost on why I'm branching this one and I'm stacking this one over here, it's because this conditional is true and this conditional over here on the right hand side is false, and the rules for a true conditional are different than the ones for a false conditional. So again, that's just to help you out if you're a little lost. So gotta flip this not Q over, gotta flip this not Q over. So that is good for that first premise. Now we just gotta look at the second premise. The second premise is a conjunction. It's Q and T, and it's true. So what makes Q and T true is if they're both true. put Q and T on all these lines like that. And now we just want to go back through, look for instances in which there's a contradiction. On this first one, I don't see one. I see T on the left, Q on the left, S on the right, and another key T on the left, so that one's open. I do have contradiction there, so that one closes, and I've got a contradiction here. Those two, so that one closes. So this one is going to be invalid. We're going to need a counterexample for it. So we have T, S, and Q. I'll write them alphabetically. So T is on the left-hand side. It is green, so it is true. Q is also true. S is false. So that is that truth tree. Again, as long as there's one open branch, it's necessarily invalid, even though there's more closed branches. It's invalid as long as there is one branch open. So here is the final one. Same process as before. Let's list our two premises here on the left-hand side. P or not Q, arrow, S not T, Q, arrow, not S. And then our conclusion is T, T, come on. There we go. T and not P. So let's look at the first premise. The first premise is a arrow. So what makes an arrow true is if the left side is false or the right side is true. And drop these parentheses, which I'll go ahead and do. So let's keep going with this left-hand side. So what makes a wedge false, this P or Q false, is if they are both false. And then we just have to flip this Q over, and we're done with that side. Let's look at this other side. We've got just S and not T. So what makes those true is that they are both true. And then we just have to flip this T like that. Now, let's look at the second premise that we've got. It is also a conditional, so we're going to branch out. And we'll have a Q on the right and a not S on the left. And then we just need to flip those over like that. And so that one is completed. Now we just need to do our conclusion, which is an ampersand and it's false. So what makes an ampersand false is if one of them is false. So T, not P, T, not P, T, not P, T, not P. Again, doing the same thing to all these branches because anything that you do above, you have to do in all the branches below. And you gotta just flip these P's, these tilde P's over to get rid of the tilde, and then we are done breaking everything down, and we just need to go back through and look for contradictions. So starting with the far left hand side, I've got a Q and a not Q there. I see that, and that's going to help me block off these two. And let's look at this next one. I've got a T, got an S, got a P. I'm not seeing any contradictions there. I've got a P and a P there, so that closes off. Then we have a TQ and S, TTQS, that all looks open to me. Then I've got PQTS, that one is also open. TSS, and that one's going to contradict up there, so both of these are going to close off. So we got 3 different open branches here. Again, we can pick any one of them, it doesn't matter. TSQ, make sure I got this. Sure, PSQP. Yep. Looks okay. Looks alright. TQT. So I've got PQTS, and I've got some open ones, so I'm going to have invalid. Need a counterexample. Get PQST. I'm again just going to look at this first one here on the left hand side. T is false, S is false, Q is true, P is false. TSQP. That's where I'm deriving all my truth values for those. Again, if we look at these other 2 open ones, there are a couple letters missing. That just means that they are not significant to it. Actually, now let's look. I think we have PQST, so we have all of them here. The only one we don't have them all in is this one right here. So, but again, when you don't have a letter there, it means it doesn't have any bearing on whether or not it's invalid or valid. So it could be true or false, doesn't really matter. But here is our lists of values for making this invalid. So this is the 10th one of this one. Again, we're just going to keep doing this for a few of these lectures here. So I'll post some more practice questions. Go ahead and try them for yourself, and then I'll give you a solution lecture to follow after that.